Hi guys, let's take a look at this question where we have a box with a mass of 45 kgs and it's being pulled by a force of 90 newtons at an angle of 50 degrees to the horizontal. The box is moving at constant velocity, which means that, say it together, acceleration is 0. 3.1. Define the term kinetic frictional force. So kinetic frictional force is the force that opposes the motion of a moving object relative to a surface. State Newton's first law of motion in words. Let's say it all together. A body will remain in its state of rest unless a non-zero resultant force acts on it. 3.3. Calculate the magnitude of the horizontal component of the applied force. Okay, they want the Fx, all right? So, sorry, let me just make this 3.3. They want the horizontal component, so they want Fx. So they want F cos theta, horizontal. So it's 90 times cos of 50 degrees, and that will give us the horizontal component of 57,85 newtons. 3.4. Calculate the magnitude of the normal force. How do we calculate the normal force? Remember, this is our normal force. All right, so what we can do is going to be the weight, Fg, minus the vertical component. So the weight will be 45 times 9.8 minus 90 times sine of 50 degrees, because it's the vertical component. And then you jot that into your calculator and you get a normal force of 372,06 newtons. 3.5. Calculate the coefficient of kinetic friction. So what do they want? They want that little symbol. All right. So I'm just going to do it at the bottom here, 3.5. So let's just go to our formula sheet. We will probably use that formula. We'll just manipulate it to suit our needs. So we can just do it this way. I think this is what we all used to. Fk equals to the coefficient times the normal force. All right. We have the friction. How do we have the friction? Because we have the horizontal component, and the horizontal component similar to the friction. So we just write down our friction there. We don't have that. That's what we're looking for. And we just calculated our normal force, 372,06. We do the taking across the dividing, etc. And we get our coefficient to be 0,16. No unit of measure. Will the coefficient of kinetic friction change if the angle of the applied force is decreased? Write only yes or no and give a reason. So will it change? No, it won't change, because the coefficient is dependent on the nature or the type of material of the surface. And that's it, guys. See ya.